my talk will be about how data science can help to get better outcome of information generated into lab. And okay. Oh, okay. So the lab today. Probably most of you are now out of paper in the labs, or at least you've got a strong initiative to do that. So we can consider that your labs are connected, automated, and that automation is creating a lot of data. So you need, of course, some initiative to standardize the data, and I won't go into it because probably some other talk will be about that, and we know all about Allotrope Foundation, for instance. But one of the biggest, let's say, initiative you may have here is data lake. How many of you got, let's say, data lake initiative strategy in your company, or maybe you have already implemented data lake? So can you raise your hand? So I was expecting a little bit more.
What a data lake is. Everybody does? Okay.
But that's okay, I'm going to that anyway. So for those who know what data lake is, this might be, let's say, something you may face. So for the other one, the danger of data lake is the following. Very often when I'm discussing with a customer, and I would say business user who's got a data lake initiative or strategy inside their company, often they are saying, you know, we've been told that we can put all of our data, structured, unstructured, on the data lake, and then after that we will be able to ask any question and get an answer. Is this simple like that? For sure, no. And I would like to illustrate that with two facts. The first is there are still less than 10% of the new generated data that are really used, analyzed. The second fact is 40% of the experiment is just a repeat of something that has been already done. And the main reason for that is we cannot find the data, the previous data. And it will be quicker to do the experiment again than really looking after the data. To solve it, most of the organization, and here the number is 70% in life science, they are moving to a platform-based approach. A platform-based approach for what? For ensuring digital transformation. And it's about really riding the digital wave. And it's very difficult because you've got more and more data generated. And the data are still stuck into emails, into static document. You don't get real-time information. And to stay agile and competitive, the only way to do that is to take a data-driven platform approach, because it's very easy to fail. So we have all our slides about what true digital transformation is. I have my own slides where when I'm asked to explain what is digital transformation, I'm always using the boarding pass, let's say, story. This is a very old one, but it's not so long time ago that we were still with paper boarding pass. So you could get it by post email, through your travel agency, or at the check-in time. Then we moved to an electronic version, and it's not digital, it's really electronic, static documents. So from the check-in time to the boarding time, if anything happened, gate change, delayed, you won't be aware. With the era of smartphone, we now have apps that can really give you information in a real time. So telling you when it's working, I know, the gate change or the delay. But through digitalization, it's even more than that. It's when you can connect everything. So when, let's say, the company can connect you to other, let's say, application like your contact and tell you in your contact who will be in the plane and where they are seated. So what does that mean in product development? So the demand on scientists has really increased. To realize the product design they need, to analyze a huge amount of data in order to gain insight from the customer needs. These insights needs to be translated into very innovative design. And to do that, you need to collaborate with many businesses, such as manufacturing, a supplier. This is really about removing data silos. It is about creating a single source of truth. And that can only be achieved by a data-driven approach. This is the what. In addition to develop the product, engineer and scientists needs to model the entire system and its interaction and simulate it under diverse conditions. That is really what model-based approach can solve it, that issue. This is the O. Oops, sorry. So let's get back to the lab. Of course, real experiment, it is critical and will be critical. So we will have to do real experiments because the product will be used in the real world, so we need to test the product in the real world as well. Experiment is very expensive, time-consuming, and most of the time, we are not taking the maximum of the information we can get from the experiment. An example is a cytotoxicity assay. Just a single pound can cost up to $1,000, so it's very expensive. So machine learning can help here. Machine learning can help to create model that will be created based on very expensive data from the experiment and in order to make very inexpensive prediction. So the real bottleneck is really the lab sum. I mean, testing for testing is absolutely not the goal. It's really important to, as I said, to maximize the information we can get when we do the experiment, bring that up, use it in a virtual mode to screen more, to get a better quality of what we are going to test, and then we will be able, oops, oh, shit. Okay, we are back, sorry. We will be able to test less. So, if we look at the product development pipeline, so it's also called gate systems. At least I can see, I can feel, I can smell, I can taste the data silos here. And even if you've got very strong project management to ensure the transfer of information, it's always going from upstream to downstream, from the left to the right, but there are not really anything done for bringing insight from downstream upstream. So adopting a data-driven platform approach will allow that every player will be able to contribute to the platform and to get all the data into a single virtual repository. And of course, then everyone through the platform will be able to get all the information they need, wherever the information will be, and to create knowledge that can be shared using collaboration within the entire organization. So I would like to introduce or to illustrate the introduction here with two examples where we have been working at BioVia. The first one is predictive maintenance. We saw that just before. It's really important. It's kind of on the top of the bubble stack we saw. But with that, with predictive maintenance, we've got two problems. The first is more the data are big and complex, more we rely on machine learning. The second problem is scientists get removed from the problem. Why? Because they lose the ability to rationalize why the analytics say what they do. It's extremely important to contextualize the outcome of analytics. And the way to achieve it is by providing an end-user experience to know what happened. This is the single source of truth. But if you can apply analytics on it, you will understand why it happened. And if you can contextualize it, you will be able to understand how to improve it and know what to do next. So in predictive maintenance, having unscheduled equipment downtime is very destructive for business. Just waiting for equipment failure, it's not really what we want today. So with the rise of IoT application, predictive maintenance has gained a bigger attention from the industry. Because now the data collection, the data processing techniques are mature enough to deal with big data, to deal with to capture, to store, to analyze this data in a real time or a batch mode. And if you can combine it with data coming from traditional systems like ERP, CRM, PLM, you will be able to contextualize the information you get from your labs and by that way improve the overall maintenance operation. And of course, by that, create higher quality product and even propose new services. So one very common way to do that is to use predictive analytic techniques to analyze historical pattern in order to predict future outcome. In our case, in that, let's say, use case, that example, what we did is to try to create, let's say, the model and the capabilities to understand what could happen in the next 24 hours and see if, for instance, for a specific reactor, one of the equipment could fail in the next 24 hours. To do that, we had to create some predictive model. And we did it by using huge amount of data from many reactors from the last or even few years and use machine learning techniques to create that model. And then provide the capabilities to use this predictive model in a real-time way to the maintenance user to understand what could happen in the next 24 hours. So the first type of persona we had to address here is, data scientists. They have to be able to get access to the data, mostly on data lake. Then they have to transform, process, create the model. When the model is created, they need to validate the model and publish the model. So in BioVia, we are providing data science platform capabilities powered by Pipeline Pilot. And here's a very short video on how very easily you can create such kind of workflow to access data in the data from the data lake, process the data, transform the data just to prepare test set and training set you will use to create your model. Then you will create the model using specific machine learning algorithm. And when you've got that model, you can start to validate it because you will get all the information to do that. So that's where I'm looking for my model, and then I will be able to look at the detail of my model, okay, and decide if it's strong enough to be published, to be used in a real-time way. So I'm skipping the rest of that video because we are running out of the time, but that was the first step. The second step is to provide that user experience to the business user. I mean, the engineer and the scientist, they need to get 360 view, and I'm running a video at the same time, where they can quickly locate, identify a reactor, for instance, and by combining information from maintenance database, from ERP, get a very, let's say, compiled 360 view on what happened and what could happen in the next 24 hours, because we can, in the real time, apply the predictive model and allows them to act before failure. So that is about my first use case. The second use case is more about scientific decision processes. So this is more on drug discovery in life science or preclinical. And here it's also where we have to access a huge variety of different data. And scientific data means biology, chemistry, data coming from outside the company, from the labs, from the data lake. And we need to connect this information, because if you have a single interface to tape on your data, but if they are still in silos, you won't get the value of it. So the way to connect, to create that network, is by giving the ability to apply semantics, ontology, scientific semantics. Then you will be able to connect. We can provide foundation for analytics, self-service analytics, and the necessary, let's say, interface application for the different personas in the company. So this slide is really about what I just said, and one point is very important, like we hear just before, security. Of course, it has to be done in a very, let's say, a secure way. Videos of an example of what we can do on the, at BioVia. Here is an application where you can access your single source of truth. You get some capabilities to create some self-dashboards in order to know what could happen. You can deep dive into it. So you can use ontology for refining your information. So here's where I will be first doing a simple text search, and then refine my data using the metadata I could create when I did the indexation or when I apply my ontology. It's important to know that we are talking about big data. So it's not about creating a giant data warehouse. It is, I mean, we cannot do that anymore. Create a data warehouse containing everything you need. What we do is just to index what we need to index for searching, but we keep the data where they are, and we can fetch the data when needed. So, and of course, you can always go back to the original source. So if it's ELN and you have access to the ELN, you can get access to the ELN. We are also using ontologies to create fingerprint of the document on the document. And because you can do it, then you can easily see what other document have a similar content to yours. Yeah, that's example using a notebook on the web. So here it is also information you may have internal, but on a hybrid environment, so it could be a cloud-based plus on-premise information. Okay, as I said, the hardest is to get value of the data, and with big data, it's even more complex. This is why Dassault Systèmes made an enormous investment on building the 3D experience platform to digitally transform entire company from end to end. The way to do that, we need to be capable to play the customer experience by bringing insights earlier in the process, insight about what the customer experience needs to be. Then we can digitally connect every stakeholder to help customer design, build, and simulate virtual product. Virtual product have to be simulated and optimized within a real-world context. That's the V plus R you can see here. The 3D experience platform can really transform the way innovator innovates by connecting every stakeholder and create a social enterprise. So, to conclude my presentation, I would like to summarize the value to build decision-making solution. You need to provide an easy access to all product and customer information. That's the search and real-time analytics. You need to provide timely and adequate answer by using machine learning and artificial intelligence. But then you need to increase, in fact, the knowledge of practices across teams. This is collaboration. This is democratization of the data science. And democratization of the data science is not enough. I mean, the example is for manager, but it's for everywhere. If you can provide self-services, you will be able to personalize data science. And that's really the key. And this is, I think, the takeaway I would like you to get is going a step further. The democratization is really personalizing the data science. So with that, I like always to end up my presentation with some value we've got in the Dassault company is if we have the passion to learn, we can expand creativity to navigate the future. Thank you very much.
Thank you. Thank you so much, Eddy. So one question for Eddy. There's one thing which I recognized, which was mentioned by Michael and also by you, but not in a different way, is about the success of thinking about working end-to-end, right? So one of the slides from Michael, he highlighted that the end-to-end is still a dream in many cases because people are not using it. It's still siloed. We're using still LIMS and ELN on the more siloed and connected way. What are your experiences and expectations when the end-to-end type strategies will be really productive in a significant part of the industry? 1 minute answer, please.
Okay, yeah. Okay, I think I agree with you as long as you keep and stay in maybe process industry like life science industry, pharma company. Because Dassault Systèmes really apply this already in many other industries, in aerospace, automotive, and this is really the case. We are providing really end-to-end solution. Our customers are really in the transformation and verifying the process to completely digitalize end-to-end. So I think it's indeed relatively new in the process industry like pharma, but why we can succeed is because we are Dassault Systèmes, but when I'm saying it's because, a couple of years ago, Dassault Systèmes acquired Axeleris, and we were very strong in delivering ELN, LIMS, a lot of solutions, but maybe not yet connected. And what Dassault Systèmes wants to do, and this is a value of Dassault Systèmes by delivering solutions through brands, BioVia and some other, is every brand can still focus on where they are good. For BioVia, life science, material science, to deliver the best of breed. But because we are on that system, we can really take the benefit of all of the brands and provide it in the platform. So this is why, okay, I'm from BioVia, and it's normal that I'm convinced, and I really believe it's the only company who can do it. Thank you.
Thank you, Eddy. Thank you, Eddy, for your presentation.